Hey everyone, I'm Venkat Narayan, a first year student at Sri Venkateshwara College of Engineering, pursuing BE in Computer Science and Engineering. In this video, I'll be focusing on electric and hybrid vehicles. Moving on to electric vehicles. An electric vehicle is an automobile that is propelled by one or more electric motors using electrical energy stored in the energy storage device. EVs are increasingly becoming a part of modern life. Its tremendous fuel economy, eco-friendliness, and smooth driving feel have appealed to many consumers. So EVs have propelled by electric motors and uses electrical energy stored in the battery. Unlike vehicles with combustion engines, electric vehicles do not produce exhaust gases during operation. So there are two types of EVs. They are battery based and hybrid. So components. So components of EVs. EVs use the electricity saved in your battery to cycle the motor and generate the power necessary for driving. This is the biggest difference in internal combustion vehicles, in which the engine uses fossil fuel to generate the power. EVs carry several components for electric power. They are motor, battery, onboard charger, and electric power control unit (EPCU). All are essential components to achieve the conversion of battery's electricity into kinetic force that drives the EV forward. Motor. The motor converts electrical energy into kinetic energy that moves the wheels. Advantage of using this motor instead of an engine is numerous. First, the noise and the vibration we typically associate with cars are minimized. Reducer. The reducer is a kind of transmission that serves to efficiently convey the motor's power to the wheel. It carries the special name reducer for a reason. The motor has a far higher RPM than that of internal combustion engine. The reducer must always reduce the RPM to appropriate level. Battery. Battery stores electrical energy and it is the equivalent of fuel tank in the internal combustion engine. The maximum driving distance of EV is often determined by the battery capacity. The higher the capacity, the higher the driving distance. Onboard charger (OBC). Onboard charger is used to convert AC from slow charges or portable chargers used at home outlets into DC. So this may make the OBC look similar to the traditional inverter, but they differ in function. The OBC is for charging and the inverter is used for oscillation and deceleration. It is not needed in fast charging since fast chargers already supply the electricity in DC itself. Moving on to EPCU. So EPCU is an efficient integration of nearly all the devices that control the flow of electric power in the vehicle. It consists of inverter, low voltage DC converter, and vehicle control unit. Inverter, it converts the battery DC into AC, which is then used to control the motor speed. Low voltage DC converter, it converts high voltage electricity from EV's high voltage battery into low voltage and supplies it to the various electronic systems. Moving on to vehicle controlling system. It controls all the vehicle power control mechanism, including the motor control, regenerative braking control, AC load management, and power supply for electronic systems. Advantages: reduces air pollution, better for our energy security, and less noise and smoother motion, cost effective and low maintenance. Disadvantages of EVs are: it has high initial cost and charging stations are limited, recharging takes time, they have limited options in it, and they have less driving range and possibility of fire hazards. Moving on to hybrid vehicles. Main components of hybrid vehicles. There are 6 main components. First is gasoline engine, electric motor, fuel tank, transmission, batteries and generator. The term hybrid vehicle in general usage refers to vehicles with 2 or 3 different types of source delivering power to the wheels for propulsion. Most common hybrid vehicles have an IC and one more electric machine for wheel propulsion. IC engines can be used to generate electricity on board to power the machine. Then components. Components of hybrid vehicles. Gasoline engine. The hybrid vehicles still have a gasoline engine, which remains to be main power source of the vehicle. Electric motor. This feature makes the hybrid vehicle particularly special. An electric motor has the ability to accelerate the vehicle by taking power from the battery. Fuel tank, it stores your gasoline like in a conventional vehicle. Due to advanced technology in hybrid cars, the fuel won't need to be used as much. So you'll have better fuel efficiency and produce fewer emissions as a result. Moving to transmission. Transmission, most hybrid vehicles will still use conventional transmission that you would find in a regular gasoline car. So new transmission being built specifically for a certain hybrid cars. Batteries. Batteries are what the power electric motor of a hybrid car. Not only that, batteries can actually take power back from an electric motor too. This is the one way like their lifespan can be preserved. Generator. If you have a series hybrid vehicle, they have a generator which gets powered by a gasoline engine. The generator can be generator power of an electric motor and helps to recharge the battery. It's basically a way of converting gasoline into electrical energy from the motor for the motor and the battery. Advantages: they are environmental friendly. It has a financial benefit. It is less dependent on fossil fuel. Regenerative braking system is available, and they are made up of very light materials. Disadvantages: they have less power, it can be expensive, poorer handling, and it has high maintenance cost. Accidents can be caused due to high voltage in batteries, and battery replacement is expensive. So the future of mobility vehicles in automobile industry promises a greener, more efficient and technologically advanced era. With electric and hybrid system leading the way, we are driving towards a sustainable and connected future, reducing emissions and operation costs for a smoother ride ahead. Thank you. Have a nice day. Bye.